What we are going to discuss today is on machine learning application in financial trading and investment. Okay, this is part of our series about AI application in finance workshop, which we intend to do throughout the month of January 2024. My name is Abubakar San Ali, and I will be guiding you through the slides. And hopefully, by the end of this project, by the end of this presentation, we will have achieved a lot of things. Okay, we will get an overview of what machine learning is and how it is used in the financial sector. All right, so as a disclaimer, okay, what we're going to discuss here is basically for educational purposes and not necessarily a financial advice. Of course, you can use the things you have learned here to implement so many financial decisions, but I will advise you use a financial advisor so that you will be able to make the right decisions based on your financial situation. So what's going to be our agenda for today? I will start with an introduction, then I will discuss the basics of machine learning. After that, we will discuss some case studies and success stories. Okay, we will see how machine learning was used in the industry, okay, especially in the investment and trading industry to enhance and boost efficiency, okay, and also increase the win rate and success rate. Okay, we will look at how we can develop a strategy with AI. Okay, we will look at an example of how to do that. We will see the framework that you can follow so that you can also integrate machine learning and AI into either your financial trading system or your investment system. We will look at a live demo. Okay, I will demonstrate a live demo for those who have time and want to go into the details. You can follow along to see the live demo. After that, of course, there will be an interactive Q&A session. So we will have this open floor for everybody to discuss and ask questions. So I welcome you once again to this exciting sessions. Okay, thank you for attending. I am Abubakar San Ali, and for those who have just joined for the first time, I am going to be your guide, okay, towards achieving what we intend to achieve. Of course, we will see the workshop goals later on. I did my PhD from Khalifa University in electrical computer engineering, where I specialize in using machine learning to develop different case studies and use cases in different applications and fields. All right. And the host institution is called as Taura Services, registered in the UAE. So we would like to start discussing the workshop goals. What do we intend to get at the end of this workshop? So first of all, we want to understand the basics of machine learning. Okay, at least if you hear the word machine learning, you should have an idea what is this all about. Okay, after that, we will look at some case studies, real life case studies where AI was used, okay, to improve and increase the success rate of trading and investment strategies. We will then finally look at how we can build and implement a trading bot using a simple machine learning algorithm called linear regression. So my objective is at least by the end of this session, you should be able to have one or two takeaways. If you can understand the first part, I will be very happy. Okay, and yeah, so technically this is these are our goals. So before we go into that, there are some few things that I would like to clarify. First of all, when it comes to trading, there are three things involved: the strategy, which the trader or investor is using to take trades and make trades. Then the psychology of the trader or investor by the time he was making that trade, and then the management. This is how he manages his investments and his trades. So these are all part of the system, and You have to put all these three together if you want to be successful and you want to be consistent as an investor and also as a trader. In the case of algorithmic trading and investing, this comes in play when you want to use computers to execute trades on your behalf. Okay.
Recording in progress.
So we are going to see how we can do that. How we can use computers to automate our trades, and this automation will define some criteria based on indicating the time as well as the price and the quantity we are going to buy. We will see how we can execute orders at the best possible price, and the main objective is to reduce the human interaction and emotions during training. So some of the benefits of using this algorithmic approach is that the efficiency and speed is high. Okay, you can't compare yourself in terms of efficiency and speed to that of a robot, you know. And also in terms of discipline, you can't compare yourself with a robot that follows specific instructions. Risk management, okay, is the next thing. When you define your risk management strategy, okay, let's say you are purchasing a company, you are buying a company, and you have some risk management techniques that you normally apply. Maybe sometimes you could be biased for one reason or the other, but if you have your process automated, risk management will become highly improved. Backtesting capabilities. So let's say you have your historical data and you develop these strategies, you can use that history to be able to automate the system that you are trying to build. If you come up with a new strategy and you want to test it as a human, then you have to test it in future purchases, not in the you can't use historical information. And that is how these bots add more benefit to our system. They allow us to go back in time. As a human, you can't go back in time. You can only try whatever strategy you come up with in the future. Scalability. So if you have many robots who are helping you, they can't be able to do so many things at a time. And that is a limitation we humans do not have, we currently have. We can't do many things. We can't be present at different places at the same time. Okay, so then now we come into the exciting part, which is machine learning or AI. Okay, so one key misconception that I would like to clarify here is, how is machine learning different from AI? Okay, so this is very good, I think, for all of us to understand that when we say machine learning, it is a subset of AI, which means that AI is the larger umbrella. It has different types of techniques that are called AI techniques. Things that have to do with evolutionary computation, optimizations, and then the machine learning on its own also. So all of this form what is called AI. So machine learning is just a subset of AI. Then there is another term that you hear around, okay, called deep learning. So deep learning is a subset of machine learning. Okay, so you have AI on top, the child is machine learning, and then the grandchild is deep learning. So the things that are making wonders now are the deep learning algorithms. These are the things that are making things happen, like the chat GPT you are using, Google Bard, all this is powered by a deep learning technique, all right, which is a subset of machine learning. So a machine learning comes with different algorithms, and under which there is a specific algorithm that follow the neural network paradigm. These are what we call the deep learning algorithms. So they are part of machine learning. And that is in terms of how they relate with AI and also deep learning. Then in terms of operation, how do machine learning operate? Basically, when we say machine learning, we're talking about systems that learn from experience. So experience here, we're talking about past data. So if you have some past data, you can pass it to these algorithms and they should be able to learn a pattern that occurs within that data so that they can help you to make right decisions. So that is basically what they do. We learn from experience. So all of them, including deep learning algorithms, they have data which they use so that they will understand how to make the right decisions. And because they are using historical information, we do not have to sit and program their behavior. Okay, they learn their behavior from the pattern which they have worked on, okay, which they have learned. So we don't have to say, okay, if somebody comes to the door, open the door, or if somebody comes and knocks 3 times, open. We allow it to be able to detect if somebody comes and knocks. Maybe he is he is like the owner of the house, a resident of the house. But if somebody comes and tries to break in, it can now raise an alarm. So we do not have to specify if somebody comes and knocks 3 times. We just allow it. From historical data, it will be able to learn anybody who knocks will be considered a resident, but those who break in will be considered robbers and thieves. So we should raise an alarm to maybe call the police. The next jargon you will be hearing out there is data science. What is the difference between machine learning and data science? All right, so data science is kind of multidisciplinary, puts so many things in place. As we said, machine learning is a subset of AI. So data science contains some components of AI, some components of data mining, some components of databases and processing. So many things come in under one single, thing you call data science. So this discipline called data science encompasses so many things. So as a data scientist, you're supposed to have an idea of statistics, pattern recognition, AI, machine learning, data mining, and the likes. So if we come up to talk about the process, okay, this is important so that you can be able to differentiate. You will see in the market, maybe in job placements, if you are a business owner, you should have an idea who you should hire. Okay, you don't want to hire a data scientist, or you don't want to hire a data analyst when what you need is a machine learning engineer, or what you need is a data engineer. Okay, you have to understand what specific role each of these guys is playing. I have been seeing so many job postings, and most of the time I will be seeing all these contradictions. Even though sometimes people say, yeah, you can just use these terms interchangeably, but it is important as maybe a business owner, if you want to hire somebody who is in the pipeline of data science, you should know exactly what you expect from him. Because if you hire a data engineer expecting him to do the work of machine learning engineer, you might be surprised, and be disappointed. So let's quickly give a brief overview of this profession. Okay, so this is the total process, the data science process. We start by a collection of data. Okay, this is what is common, right? So Facebook, they have this huge corpus of data from our interactions on social media, Facebook. Then they get this data, collect it, and they will clean it, to make it very nice, maybe in tabular form, so that it can be easily processed. After they do this cleaning, they can do some exploratory data analysis. Okay, here they try to see are there outliers, so that maybe they can be able to figure out bots. Those bots that were disturbing people on Twitter, sending people spam. So maybe if they see the way you are interacting with the social media platform, they could say, okay, this is possibly an outlier. This is that. So that is the exploratory data analysis. Okay, sometimes you also do some visualizations. You can be able to tell, okay, this is the percentage of male gender, female gender, and the likes. You put things in order like this. Okay, the percentage of people between this age, adults, teenagers, young adults, and what have you. So all this is part of what we call exploratory data analysis. Then we have the model building. Okay, so this is where we're talking about trying to learn from the data so that we can recognize the patterns within the data. And once we were able to recognize these patterns, then we can be able to make deployment. Okay, if for example, let's say I have data of housing price. Okay, I know, like, okay, let's say Los Angeles, I have this huge database where I have, list of houses and their respective prices. So this house cost this house cost this, and then I try to just sit down and try to figure out the pattern. Why is this house priced at this amount? Why is this house priced this amount? So once I figure out that pattern, so that whenever you give me some description of a house, I can easily tell you, yeah, this house is going to cost you this if you are going to buy. So I've already developed a model in my brain. With this model in my brain, I can be able to make predictions. Okay, so this is what we call model building, the art of making those patterns. Okay, and the last thing is called the model deployment. So this is like, okay, you have gone to school, you've learned this thing. Now it's time for you to start and go out there and become, let's say, a real estate broker. So this is when we do the deployment. In our case, for example, after we train the machine learning model from our historical data, okay, to make decisions, we now want to take it maybe and deploy it on our website so that when our customers come, they type in their requirements. Okay, I want a house like this number of uh, rooms, this type of neighborhood, and what have you. Then our model will be able to predict them the cost they are going to incur when they want to buy that house. So this is the whole data science process. So those guys who are involved with the first part, the first two parts, that is, these are the guys who will collect the data, let's say from the website, and clean it, put it in tabular form to make it nice, remove all the noisy parts of the data. We call these guys data engineers. Then you have the data analysts. These are the guys who normally they get data that has already been collected. It has been collected. They are not the ones responsible for the collection, but sometimes they get to do the cleaning. They have to make it look good so that they can carry out their analysis. So when it looks good, they now pass it into the pipeline, and then they will be able to start generating all those bar charts you see, pie charts, and what have you, to make visualization so that you understand things visually without having to read tables and what have you. So this is what data analysts do. But then the machine learning engineers, what they do is to say, okay, give me your data, the cleaned one. I don't want issues. Go and collect your data. I don't know how you do that. Clean it for me. Just give it to me. I'm going to train something that will understand the pattern within the data and be making predictions for the future. So that is what machine learning engineers do. Once they build this model, then they will go and deploy it so that it will be making that house price prediction. Whereas data scientists does everything, starting from collection down to model deployment. I hope this is clear. All right. So there have been so many examples of using, data science and machine learning in real life. For example, there has been a very notorious case where Target sent a lady some pamphlets or flyers related to offers. They are giving her discount on mother and child, products. And this flyer was received by her dad, who went to Target and started trying looking for the manager to complain. Why are they sending his teenage daughter flyers about pregnancy, babies, and what have you? So apparently, Target comes to know about the pregnancy of the lady before her dad or even anybody in the house. So these are some of the ways that these guys use data science. So they try to understand your shopping pattern. Once they realize your shopping pattern, then they try to start giving you suggestions and recommendations so that they know, because you are now going through this is the most likely thing you want to buy. Okay? In elections too, this is where Obama came and he used election and who won the election, of course, due to largely social media. He used Facebook and was able to garner lots of buzz from social media. So the thing is, if you understand what data science can do and you want to apply it into whatever pipeline you want to use it, you will likely improve your success rate, decision making, and so many things. And there are so many concentrations in data science. I'm not going to go into that. But the main idea is just we want to automate what we normally do. So if you have a model that you train it to do the same thing you used to do, okay? Let's say you are a real estate broker, and at a day, maybe maximum you can be able to go and maybe scout 10 houses, 20 houses, and collect the data, come and maybe start to price and all that. But if you have this, robot that you train based on your own past experience, you have all this data that you stored, then you train that model and it is now able to make predictions just like you. Okay, so that's why, and the reason now it is making huge news all the time is for these three reasons. One, we were able to get huge amount of data. 50 years ago, when we had the AI winter, we do not have that much data to train these models. Not only that, we lack the computational power. Our computers were very slow. Okay, some of them have RAMs in the orders of kilobytes. So we lack the computational power. Our algorithms, some of them were archaic. We do not have some of these amazing deep learning algorithms that we recently come across. Although most of them have basis from all the years back, but all these developments are because of these three things. So because of this, we were able to have so many different applications in science, commerce, and so many things. But as I said, AI is not machine learning. Some of the applications that you are always encountering include email filtering. Okay, if you look at your Google account, Gmail account, for example, you will see your emails, separated into different folders. Some will be added in your inbox, some will be added to the promotions, some will be added to the spam folder, and all this. So this is a machine learning in action. It is the one that once it receives the email, process this email, make sense of it, and tries to see which of these folders does it belong to. Speech recognition, this is very common for those who use Alexa and the likes, Siri. Predictive analytics, this is used in companies to predict, let's say, inventory. You have historical data of your inventory turnover, and you would like to make predictions so that there will be no situation where customers will require or need a product and you are not, or you are out of stock. So if you use predictive analytics, you can be able to predict which product is going to be in high demand. You go and stock that product. So some of the examples and the problems is what we call classification, and we will discuss more about this. Okay, here what we are trying to do is to see how we can see a picture and we can tell whether the picture is that of a cat or a bat. Okay, so in a nutshell, machine learning differs from traditional programming in the sense that machine learning is not programmed. Okay, it learns from data. You give it data, you give it the output, and it makes prediction. As simple as that. Okay, tell it, okay, if a house is like this is going to be priced. But if it is traditional programming, maybe you will come up with a formula. Okay, 2-bedroom houses per bedroom, that is to $20,000 plus the neighborhood, the crime rate times this. You come up with a formula and then you write that down. That is explicit programming, or what we call traditional programming. Doesn't work in this case. For machine learning, it doesn't work that way. Okay, it does give it the data, we'll learn from the experience. All right, so now this is where we will talk about the types of machine learning and the tasks they do. And if you take this home, I would say this is almost 80% of the knowledge you need to know as a general knowledge for every person. If you know this, at least you will be able to make some some decisions. You can make some decisions about machine learning and AI. Okay, because it's important to know a tool and to know what to use that tool for. Okay, because machine learning is a tool. If you don't know exactly what that tool is, that is one problem. But you can know the tool, but you don't know how to use that tool. That is another problem. I know many people know what machine learning is, and that is what we've discussed so far. Now the question is, how then can we use machine learning? So by if you look at it from task perspective, machine learning can do three things, or we have three broad categories of machine learning. There could be others. For example, the supervised, we have what we call the semi-supervised or the self-supervised. So we have so many of them, but categorically speaking, we have three main classifications of machine learning. And the first one is called the supervised learning. Okay, supervised learning approaches, these are the systems where we supervise the learning that is undergoing. Okay, this is like what you do in schools. Okay, let's say you have a math teacher, he comes, gives you examples, solves some algebra, gives you example, tells you the answer, and then later he tests you with exercise, give you a homework or an assignment to go and do. So this is supervised learning. You have somebody who taught you the process and he even told you the answer. Okay, it's like that image you saw before me. I give images of a cat and images of a bird, and I was given image of a cat. I was telling it, okay, this is a cat and its image is like this. Okay, this is a cat, this is a cat. So I give it the image as well as the label. We call that the label or the target. Okay, so this is a machine learning algorithm. Supervised learning. Okay, so this supervised learning comes in two shapes. We have what we call regression and we have what we call classification. Okay, so the regression tries to predict a numerical number, a numerical value. The example I was given earlier about saying house price, to be able to train this thing to be predicting house price. House price is a continuous number. Maybe it could be 100K, 110, 120, it's a continuous spectrum like this. So this is a regression. So if your problem is like this, you should know that, okay, this is a regression problem. That is one. So the technique I'm going to use is a supervised learning approach with algorithms that support regression, because many algorithms differ in terms of their operations. Some will work with regression, some will work with only classification. So what is classification? This is categorical, it predicts discrete values. For example, in this example here, cat or bird or cat or dog, we are discretizing the prediction. Either it is this or it is this or it is this, As I told you earlier, you have your Gmail inbox, so you can say either this email belongs to the inbox folder, or it belongs to the promotions folder, or it belongs to the trash or spam folder, So this is how you do classification. However, regression, you predict continuous values. But the problem is, during learning, there is a supervisor, there is somebody who tells it, okay, look at this, this is the answer. Look at this, this is the answer. So this is supervised learning. You need historical data. You need data to do a supervised learning. Unsupervised learning approach, this is similar to supervised in the sense that it also requires data. Okay, so you bring in a lot of data, but this time around, there is nobody to tell it, this is an image of a cat, this is an image of a bird. Okay, you allow the model on its own to try to understand the pattern. So let's just give it images of cat and bird. Then it will try to make some clusters to say, okay, I think images of cat looks like something with 4 legs, eyes in this way with 4, and all this whiskers and what have you. So anything that comes, I will just put it in this folder, or I will say you might likely belong to this guy. So during the training, we do not specify that this is cat, this is a bird. We did not do that. We just allow it to work on its own and try to figure out something. Okay, reinforcement learning. Now this is my this is my favorite. Okay, reinforcement learning, because I worked with it for quite a long time. So what does reinforcement learning do? This is what we have in the time, like this is the type of machine learning that tries to learn using trial and error approach. You just throw it out there and it tries to learn. It's like having a kid who is trying to learn how to ride a bicycle. Nobody is there to teach him. He is just allowed, go, this is the bicycle, go and learn. So he will ride the bicycle, maybe he will fall. He will run, then when he falls, he get penalized because he feels pain. But then when he maybe tries to step on the pedal and maybe move some distance, he is happy. He gets some reward. So this sense of reward and penalty tries to make him to try to always make the right decision. Okay? So it learns by trial and error. That is reinforcement learning. It doesn't have any historical data that it is going to use to learn. Nobody is there to supervise its learning process. We just throw it out there in the world and it learns by trial and error. Okay, so, well, I have actually described all these things in a bit, but maybe I should talk about a use case of regression. As I told you earlier, we can predict house prices. In the financial market, we can predict stock price. Okay, we can say, okay, if the stock price yesterday is, let's say, 100 of Apple, okay, $100 per share of Apple. If something happened, okay, so for example, we can say if there is a good news, okay, then likely stock price of Apple will become 150. So we are predicting, and the dependent variable, or we call it the feature or the characteristics or the attribute that made us make this prediction in the example I made was the simple news. Okay, news sentiment. Are people happy about Apple or not? So based on the sentiment of people, I make this decision. Okay, I make this prediction that the price is going to be this amount. And for the classification, where you put things in categories, okay, some example or use case in the in the financial world is to say, if you have been brought with an opportunity, maybe somebody brings a business for you, a business opportunity, or you spot an opportunity in the market you want to buy. All right, so the decision of buy, not buy, buy, not buy. You can see this is a classification decision. So if, for example, you have some expert, let's say expert trader who always makes, good trades. So he knows when a trade is supposed to be, executed, and he knows which trade not to take. You can look at his trade history, look at all the things he did in the past, then build a model to try to learn his pattern. Maybe this person cannot explain the reasons, he can't explain the logic behind most of his decisions, but if we give all his historical information, all the decisions he made along the way to our algorithms, then these algorithms will figure out the pattern upon which this guy is making his decisions. Then we will now have another expert to be doing his job, So that is something, like which we can do. You can have it in this way. All right. So reinforcement learning, as I said, we talk about things that have to do with risk management. For example, when you are talking about the financial world, and risk management could include, for example, when should I sell the stock of, let's say, Apple? Okay, should I sell now? Should I sell later? Should I even buy? How many shares of Apple? How much money should I invest in Apple? All these are decisions, right? That you can't easily say, it's easy. So what we do normally in reinforcement learning is we throw the agent there. We tell him, okay, go. Keep trying, in the simulation environment. So he will just be buying Tesla, or buying Apple shares, buying, selling. Slowly, he will be figuring out, okay, I think if I use all of my money or all of my account balance to buy the stock, I always blow up the account. So maybe let me reduce it to 50%. Let's see what happens. Then he reduces it to 50% and he sees that, okay, now I'm not blowing up the account easily. All right, what if I make it 5%? Then he tries 5%. Okay, now it's good. Okay, when am I supposed to exit this trade? When should I sell the company? Okay, so maybe when things happen, when there is a good news or when there is a bad news about the company, or when their return, you look at their fundamentals, and you realize that their intrinsic value is very terrible, that is when you sell. Like people are, like it's been overbought. Many people are buying it without looking at the fundamentals. You said, okay, this is like this is the right time for me to sell this Tesla stock and just escape. So he will be trying these things, try this, try this, try this, trying so many things. At the end of the day, he will come up with the best values. Okay, the best value for position sizing is 2%. Best value if I'm trading Tesla to go out of the trade is I'm expecting Tesla will reach 500. Once it reaches 500, I will sell. But if I'm wrong, maybe it drops to 200, I will sell. Okay, so all this reinforcement learning can learn. So you see the difference here in reinforcement learning. We didn't go and get an expert data from somebody who has been trading and was doing well. We just allow it to go into the simulation environment and learn by trial and error. And that's why I love reinforcement learning. The only issue is sometimes the behavior can be very terrible because it might learn things the wrong way. If you think about the example I gave about motorcycle, or bicycle, you have a kid who tries to learn how to ride a bicycle. He might learn to ride a bicycle backwards. That is not what we are looking for. We want him to learn how to ride it looking forward, but he might learn to balance off backwards. So these are some of the issues that you can come across. Clustering, this is an unsupervised, and as I told you earlier, that here there is nobody to supervise. Okay, you just give it the data. Okay, you also need the data. You just give it the news, and then it tries to see, okay, based on this news, I think this is a good news about Tesla, so let me read it. This is a bad news about Tesla, let me read it. This news has no information, I keep it aside. So clustering and classification could look the same. The only difference is in classification, you already informed the model that this is a cat or this is a good news, But in clustering, you allow the model on its own to figure out a good news and what a bad news is, even though on its own it doesn't know good and bad, but it says that these guys look to be from the same group or the same cluster, I will put them together. These guys also look to be from the same cluster, I will put them together. But if you ask it, is this guy good or is this news bad, it doesn't know which good is or bad, but it knows that these guys belong together. So this is clustering. Okay, so for example, as I said, in the financial world, okay, you can have all this news aggregation, you put it together, and based on that, you make your informed decision. The machine learning process, this is just as I explained earlier. How do we do it? We start by collecting data. So whatever I'm going to do, as long as it's going to be machine learning, I might need to collect data. Okay, once I collect the data, I need to prepare this data. Okay, clean it, remove all the noise. Then I will need to choose a model. And the choice of this model will depend on the problem. Remember, I told you that we have different types of problems. House price prediction is a different problem than cat and dog classification, So we need to choose the right model. Some models can do continuous prediction like house pricing, stock pricing, business pricing and all that, business valuation and what have you. Whereas some models can only do classification to say this is a good business, this is a bad business. But they cannot tell you what is the price of this good business, what is the value, how much should we value it. It doesn't know. So that is why I explained that part very rigorously so that you understand. So once you pick the right model for the right problem, you will then train the model using the data so that it learns from the experience, recognize the pattern, and then once it recognizes the pattern, then you would like to evaluate its performance. Just like your teacher, once he teaches you and he realizes maybe you have good understanding of the concepts, then he will say, okay, test, exam, let's see. Did you really understand what I taught you, or you just cram? You just memorize the concepts. You have no idea how things are. And memorization in machine learning, we call it overfitting. We call it overfitting. So we have a term for it. So if your model is memorizing your training data, it's not learning the pattern, you say the model is overfitting. Okay, so we evaluate the performance. If we are happy with the performance, we keep tuning it until when we get the best, which we will now deploy in the real world. So you will see, so we're going to build the live demo later. I will follow this process step by step until I finish training the model. Then I will use this model to deploy it in the financial market. So now I'm moving to the next section. I think I have been speaking for quite a while, almost 40 minutes. So if there is any question, please ask. I hope I'm not too fast and I hope I'm being very clear. If we are good, you can just give me a thumbs up in the chat so that I know I can move on. Okay. So the next thing I would like to talk about are some of the case studies, how the machine learning and AI is used. Okay. And our, of course, application so far is in trading and investment, how it is used. And as I said earlier, it is used, for example, to enhance accuracy, which we saw. Not only that, okay, yeah, thank you, Kata. All right, yeah, thank you. All right, yeah, so yeah, coming back. All right, it also helps us to identify complex patterns and trends. Okay, some trends maybe you can't easily tell from your naked eye. Using naked eye inspection might be difficult, but if you have these ML models, you will be able to identify good trends and bad trends. Okay, as I told you earlier too, we have some of the key concepts, and I've talked about the algorithms. These are the recipes. Okay, these are the models. This is how we model. You can consider algorithm as the teaching method of a teacher. How does this teacher teaches his students? So the teaching methodology is what we call the algorithm. Okay, so in our case, for example, how do we teach this machine learning? And the model is the student, of course. So we want to model him in our own, image. That's what we normally do, right? You are a good teacher and you want your students to learn. You want to model them in that regard. So the algorithm is the teaching methodology. The model is like the student. The data is like the examples, exercises given in class. Okay. The model training is that teaching process, how we teach that model, that student. Okay. Applications in financial market, as I mentioned earlier, I've talked about price prediction. I've talked about algorithmic trading, and I've also talked about risk management. I've talked about this. It has so many benefits to traders and investors. For example, data-driven decision making. Okay, so you can use data, historical data, to help you make the right decisions. It minimizes your emotional bias. If you are trading, you might be emotionally biased, especially if you like a certain stock, you just want to keep at it, even when it is actually going terrible. It improves the trade execution speed. You cannot compete with a machine. Computers are faster, so we cannot compete. So, I think anybody who follows the financial market, the stock market, will know of Gene Simmons, right? The guy behind Renaissance Technologies. They call him the most profitable trader in history. Okay, his company Renaissance Technologies. In their companies they were using all these algorithms. You got so many brainiacs, mathematicians and statisticians who come and they were building models. You got so many quants who know machine learning and stuff like that. Brought in so many supercomputers. So yeah, the guy was a billionaire. Started. You were saying that if he had started investing at the same time with Warren Buffett, then he would have been a trillionaire by now. But he only did it for a short amount of time. But anyways, it worked for him. That's the Renaissance Technologies. BlackRock, this is the biggest company in the world that owns almost everything. So every big company, you will see that BlackRock owns a share. So they have one tool one AI they call Aladdin. Okay, they use it for risk management and investment. So it looks at a company, it does all the all the expertise of their previous trades and purchases and their investments. They collect all this data. Okay, once they collected the data, they put it through the machine learning process so that the model will be able to realize and recognize the patterns that lead to good investment and the patterns that lead to bad investment. Okay, so this is some of the amazing things that are being implemented using AI and machine learning. Citadel, another guys, big guys also, they use it to do high frequency trading. So these guys might be doing investment at BlackRock, but then Citadel, Jim Simmons of Renaissance Technologies, these are traders. They buy and sell. Okay, and high frequency trading normally comes about the type of trading that requires fast execution of trades, maybe in milliseconds. If I am not wrong, I think it was Citadel that spent around $500 million to connect fiber optics cable from their headquarters to the Nasdaq Stock Exchange. You know, so that they will be able to be getting data and information in the orders of nanoseconds. So yeah, that's how fast they enter and get out of trade. You can't expect a human being to do that. Of course, you need robots and algorithms to be doing all that. Charles Schwab, investment bankers, right? So they have something called robo advisors that is powered by machine learning. So when you go to them with your money, you will follow a certain process, fill out your form, all your details, and then this robo advisors will be giving you personalized investment advice. Tell you, okay, maybe based on your financial situation and maybe your risk appetite, this could be a good one for you, this could be a bad one for you. JP Morgan, yeah, so for those who knows, JP Morgan, one of the biggest also banks, yeah, they also have so many use cases of machine learning. They have something called the Lobsing program, and it is also used for trade executions. So these are some of the applications of machine learning or use cases in case studies. Okay, these have been now implemented, and they are currently, some of them are currently in use in these companies. So the idea is, how can you also try to leverage this power, okay, that was previously only at the hands of those giants, to also improve your own life or business or trading, whatever it is you want to do. So now we are going to go into seeing the framework, the step-by-step framework of building a system, okay, that will be able to do things for us automatically. And of course, what we want to be doing here is trading, how it will be traded, and we will see how machine learning can further help that regard. Okay, so I have now finished with the things that have to do with machine learning. We are going to go into some little technical part here. I will try to make it as seamless as possible, try to make it as clear as possible. But if you do not understand any, like most of the things here, do not feel bad. Some of the things I will discuss here are a little bit technical, okay? But as I said, recordings will be made available on our YouTube channel as well as our app. So you can always have another go at the recording to further enhance your understanding. So the tools we will use, as usual, when you are building anything, you need tools. And our tools are also going, some of them are AI based tools like ChatGPT. I'm going to use ChatGPT Plus. After testing so many different models, I think this is the best in terms of accuracy. Of course, I have been using Google Bard previously. It still will work, but sometimes Google Bard produces codes that come with lots of bugs. So it takes a lot of time to debug those codes, and the time is not something we have, right? Google Colab. So this is a tool that is used to execute codes. So we call it a development environment. So the code we are going to get from our ChatGPT Plus, we need to run this code. And in order to do that, we will take this code, copy it, and paste it in Google Colab. And Google Colab is a Python environment, will be able to allow us to do that. Because it is a Python environment, it requires libraries. Python comes with libraries. These are packages that were developed by other software developers and engineers, as well as programmers, that enhances and allows other programmers to carry out functionalities easily without having to code everything from scratch. So they do most of the work. All you have to understand is how to put things together. Okay? So we will use the libraries and then the Alpaca API. Okay, Alpaca API is what will give us access to real market. So the first three we can use them and we will train things but in house. Okay, we will not be able to see. We will use those first three first of all to do our in-house train. So we will train our model. We will train it using these three. Because when training the models, you need historical data so that it will learn. So it's like the student, right? So we have all this information and we teach it and it learns. So when it learns, then we will throw it out there in the real world. Okay, go and execute threads for us. So in order to do that, we need the Alpaca broker. Alpaca brokers will provide you with a platform which you can trade in, and the API is like the bridge that is established between that broker platform, the brokerage platform, and your code. Okay, so we will use this to be executing our codes remotely for us and anybody who is here. I think everybody knows what ChatGPT is. So it's a large language model. You give it instructions and it follows and gives you a response. So we will use it to build our strategies. We'll tell it our ideas and it will give us code. Google Colab, as I said, is Python based, it's free, supports collaboration, very good for backtesting. Okay, I have to make this clear. Very good for backtesting. Okay, we can easily test our strategies to see what happened. But the problem is we are going to have something that will run forever or that will run for hours or years or months or weeks, then it might not be the ideal tool. Okay, so the libraries we're going to use, we have pandas. Okay, pandas allows us to analyze data. So we'll get data and we analyze it. It's a library, it's a package. So many things have been made very easy using pandas. Otherwise, without pandas, you'll be suffering and struggling to process and analyze your data. NumPy, for data vectorization, matplot library for visualization. So all those pie charts, bar charts you see, we normally use matplot library to generate them. Y-Finance, this will give you access to information about assets. Okay, the asset could be stock, it could be crypto, it could be forex. It doesn't matter. All information that is based on it, the Yahoo Finance is like the Yahoo Finance. You go to Google, type Yahoo Finance, it brings you all this information. So you will see news, you see so many things. All the fundamentals, all the components of companies. If you are talking about companies, which is about crypto too, you will see everything. All those ratios you need for fundamental analysis. Yahoo Finance provides all that information for you. If you don't want to do fundamental analysis, or you want to do it in collaboration with technical analysis, then you need another library that will provide technical analysis for you, and that is called TA library. Okay, the technical analysis library. Okay, of course there is another one, TA, just TA. Okay, so this gives you all those technical analysis tools. For example, the moving averages, MACD, RSI, average true ranges, and so on. All those are provided by this library. You do not have to code them from scratch. Scikit-learn, this is the thing that supports our machine learning. So as I told you, we have our machine learning algorithms, which are the teaching methodologies. Okay, you can consider them like that. So we have different teaching methodologies and learning methodologies, right? So those algorithms, all of them have been coded by other people and have been uploaded to scikit-learn. So all you have to do is just to call scikit-learn and tell it, okay, scikit-learn, I want to use linear regression. So it will give you the code and everything. It will hide it for you. It will just tell you, give me this, give me that. I will do everything for you. So that's what scikit-learn will do for us. TensorFlow, this is for deep learning. As we said, deep learning is a subset of machine learning. So this is a library developed by Google engineers, okay, for deep learning applications. PyTorch also for deep learning applications. PyTorch is developed by Facebook engineers. So you can see, so you can use either of the two if you want to do deep learning operations. OpenAI, for those who know OpenAI, everybody now has an idea one way or the other of OpenAI, maybe via ChatGPT. So they also have their library that provides different packages. For example, so many things that have to do with large language models, and also the gym, OpenAI gym, that is used for reinforcement learning and so on. I have talked about Alpaca API. Okay, I've given an overview, but I would like to mention that it is free compared to others. Like you have so many other brokerage accounts out there, interactive brokers, for example. These are there, but most of them are not free. Some of them that are free require huge amount of capital before you can use them. Okay, like Owanda requires monthly subscription. I think the lowest amount is $400 per month. So, but Alpaca provides the API for free. And I always say we do not want to provide these APIs for people to automate their trades because they know that will increase their win or success rates. So you don't want that to be the case. So yeah, that's Alpaca. It's free and we're going to use it as well. Okay, so the strategy overview. What we are going to do, this is what we're going to discuss a little bit out here, all right? Um, okay, so the tools, I believe, clear. Before I move to the strategy, this will show you how machine learning is going to be used, for trading. Yes, just give me a thumbs up. This is clear. Okay, so I will assume it is clear. Yeah. All right. So when you are building an algorithmic bot, okay, you need three things. You need to have a signal, and this happens not just trading in the financial market. This is for trading in general, right? To our trading, we need to have a signal. This signal will tell us when to buy or when to sell. If you are buying house, you are a real estate, let's say mogul, you buy houses, there has to be a reason for you to buy a house or not, you know. So that's the signal. Other type, this happens also when you are, let's say, buying a house or you are buying a business. Do you want to buy immediately when the opportunity presents itself? Or do you want to wait for some time, until maybe when this opportunity improves? Maybe you feel like, yeah, they want to sell this house. Maybe if I wait tomorrow, they might reduce the price. So that waiting, hoping the price is going to be reduced, is called limit order. That type of order is called limit order. But the case may be where you are saying, yeah, I think people are buying, let's say, GameStop. Seems like the stock of GameStop is increasing. So there is that likelihood that it will keep on increasing. So today it is 100. I think the price could reach 400. I'm not gonna buy now. Let me wait to see if the sentiment is the same with everybody. Will people continue buying? So once the price reaches 150, I can say, okay, this is my confirmation, then I will buy. So this is a stop order type. Risk management, this is how you intend to get out of the trade. You don't intend to hold in things forever, right? You intend to hold things maybe for a certain amount of time. For example, if you buy a house, maybe You will want to renovate it and sell it maybe at a better price. Okay. You don't intend to hold it for, let's say, more than 2 years until you find the right buyer who will come with the right price. So that right price that you are waiting for is your take profit. So you might say, as long as I get 100% return, I'm happy to sell. 50%, I'm happy to sell. So that percent, that amount is your take profit. So this also has to be implemented in the financial market. Otherwise, then you don't know when to get out of the trade. Maybe you will overplay your hand and then you lose all your money. Stop loss, this is saying like if I make wrong prediction, I'm hoping things will improve, but then things start to get worse. So once that happens, I will just get out of this trade. I will sell. You bought a house, hoping that the real estate market will boom, then it starts to crash. So you don't want to stay in the market and lose all your money. Maybe you will say once the real estate market drops by 50%, I'm going to sell and just take my losses and go. So that is stop loss. Position sizing, this is more of like diversification. You don't want to have a situation where all your money you put it in one stock or one business, for example. That's the concept of never put all your eggs in one basket. So you want to diversify. So position sizing has to be also implicitly stated when you are making trades. Okay, you have to tell the robot, okay, don't use more than 2% any to buy into any opportunity you come across. If I have $100, don't use more than $2. All right. So this is the components of AI. So let's see. This time around, one of the techniques I'm going to use is called the regression analysis. As I said earlier, we have different types of teaching methodologies, okay, which teachers can use to teach their students. Here, the methodology used here is called regression analysis. It comes in different shapes, okay? We have what we call the simple linear regression, and we have what we call the multiple linear regression, okay? So, as the name implies, regression, we are going to make predictions of continuous values, right? For example, house price, stock price. We are making predictions for a continuous value. We are not doing classification or categorization. No, prediction of a continuous value. So the simple linear is saying that I am going to be making my prediction based on one single parameter. Okay, I'm going to predict that the Tesla stock is going to reach 300 based on one single parameter, which could be its price to earning ratio. If the price to earning ratio or the Sharpe ratio or something like that is above a certain threshold, I am going to buy because I know the price is going to be this. Okay, that is the point. Like you have the earning ratio, let's say a price to earning ratio of 2, then you multiply that price to earning ratio with the current, let's say, stock price, and that gives you the prediction. You do this multiplication and you get the prediction of the Tesla stock. You can come up maybe with your own ratio. Maybe you try to figure out some ratio on your own. Then whatever that ratio is, just multiply it by the current price of Tesla. That will give you the prediction of Tesla maybe in 2 days, maybe in 1 year. This is simple linear regression, just one independent variable. The case of multiple linear regression, here it involves two or more variables, independent variables, okay? We call them features, we call them attributes, okay? So if you hear me saying features or attributes or variables, independent variables, sorry, I mean the same thing. So multiple linear regression, maybe for the house, you want to predict house price. It could be one feature could be number of rooms. Another one could be, let's say, crime rate in that neighborhood. Even the neighborhood, the city, all these are going to be determinants that will determine the price of the house. How old is the house? Is it new or old? Something like this. So this kind of problem is a multiple linear regression problem or multiple regression problem. So when I say linear, okay, that is the regression part. So we have talked about the simple and the regression. So So why linear? Why am I saying linear? Okay, so linear is when we are talking about things that increase with an increase or decrease with an increase. If there is a linear relationship, just as you can see here in this plot, we have a linear relationship. Let's say this is house price. Okay, so as you increase, for example, the let's say the more you go down the crime rate, as the crime rate increases, the house price decreases in that neighborhood. So the more the increase in crime rate, the less the price of the house. Okay, so even though it is an inverse relationship, but it's still linear. In this kind of case, we have non-linear. Okay, yeah, there is a kind of exponential, relationship between, let's say, house price and number of rooms. We don't expect that for every additional room, house price will be a multiple of those number of rooms. Maybe from 1 to 4, we will be seeing some linear relationship that for one house it's $1,000, for 2 rooms it's $2,000, for 3 rooms 3,000, something like that. But it doesn't mean that it will continue like this for 100 rooms, $100,000. No, maybe it will start to be decreasing. Maybe for 20 rooms it will not be 20,000, it will be like 15,000. For 21 will be like 15,500. So this kind of relationship we call it non-linear. In this case, we even have zero relationship. So no relationship. See, there is no relationship. And this you could assume maybe, let's say, the relationship between house prices and what? Yeah, let's look for something that have no relationship with house prices. Yeah, okay. The relationship between house prices and the sales of Terminator tickets. Who cares? Like, just because they are selling tickets of Terminator, does that mean house prices is going to shoot up? Or if people didn't go and watch Fast and Furious, then house prices will crash. So something like that. So no relationship between these guys. So now with this idea in our mind, okay, we would like to come up and try to make some predictions. Okay, and this is an example I told you earlier about the home market value. We want to know how much a home market value is. If we know the house age and the size of the house, we can predict the market. You can plot these data, you can plot them, and you can see something like this, which means house market value against house size, the square feet. Look at it. There is a linear relation, meaning that for every square feet increment, the house or the market value of the house increase. Okay, so this is just to show you how these things work in real life. And normally we will have an equation, a mathematical equation that will be formulated. Okay, so this line is something. So this is something we're going to use. This strategy, let's say I know this are the Tesla stock. Okay, and this is the number of, for example, this is the price to earning ratio. So I know for yesterday, if this is, so I can extend this line, for example. Okay, let me draw this. Okay, so I can extend this line like this. This is the current price, for example. Okay, so I can make a prediction. If this happens to be this value, then most likely this is going to be the price. Okay, so for example, I'm talking about Tesla. Let's say this is the price to earnings ratio, PE. Okay, so then we have a PE of, let's say this is 2, for example. However, people are buying Tesla at the price around this place, around this place. But then if you look at the trend of our regression line, it's supposed to be this. This is supposed to be the price of Tesla. But currently people are buying this. Okay, so this is a good indication for me to say, you know what, I'm going to buy Tesla, because this is just maybe some speculation going on. But I believe following this trend, Tesla is going to reach this level. Tesla is going to reach this level. So maybe I buy it now, it is 200, okay, but I know this is the PE, then I will just wait for it to reach 250. I know based on my line, this will be 250. Once it reaches 250, I will take my profit and I will go out of the trade. So this is just the strategy which we are going to use. This is just one simple strategy just to show how machine learning is actually used in the yeah. And this is the overview actually. So I'm not going to go over it again. Okay. So in terms of risk management, right? So the things that we discuss normally when it comes to risk management are the position sizing, right? So as I said, we don't want to put all our eggs in one basket. So a 2% is recommended, okay? Especially if you are just starting and you don't know, you are not George Boros, so who bankrupted the Bank of England, borrowed money, put everything he had, made $1 billion. So you don't know that, You are just starting, you just look at you look at, let's say, Tesla, look at the fundamentals and everything, you would say, okay, why don't I put 2% of my money in Tesla? Okay, and then another 2% in Apple, this kind of thing. So if you are just Soros, you are very confident, you have all that experience. If somebody can go and give us a history of his trades, we can train a machine learning model so that we will have a just Soros AI for making decisions for us. Okay, I think I've seen an AI for Warren Buffett, some AI that tries to mimic Warren Buffett's style of investment, looks at the history of what he was investing in, and then tries to do the same thing. Okay, so this is, let's say, the position sizing. In terms of our take profit, you will be noticing our linear regression curve, okay, our line. So once our line starts to decrease or to start to change trend, for example, we are plotting and we saw our plot is supposed to be like this, and based on the data, we made this plot, okay, and we made the prediction and we buy into the product. So we are expecting, as I said, once it reaches this, we are going to sell because people are now currently pricing Tesla here. So we are just waiting for it to reach this. So once it reaches, this is our take profit. But then the stop loss, that's where now we will monitor this line and we will keep plotting it and updating our model. So maybe once our model shifts, from here, let me use a different color. Once our model shifts from here and it changes direction to here, meaning that this is now the new price. What people are buying is actually the price. Tesla is not doing well. Therefore, I will just say, okay, since the slope of this line has decreased, it's time for me to get out of the trade and just close my account, or my position, cancel the order, get out of it. Okay, so this is how we intend to manage our risk. So the position sizing, TP, and then the stop loss. Okay, so we will set them as I indicated here, and once this is done, we will move on to the next thing. So let me clear this. Okay, so now we have everything in place. Okay, we will automate our orders so that they become automatic. Okay, and to do that, we will set a scheduler. This scheduler is going to wait every maybe 1 day or every 1 month. So if you are like some long-term investor who invests for the long term, okay, you want to wait for a certain amount of time. All right, so once that time reaches, every month you try to come and look at your portfolio and you do some rebalancing. You rebalance your portfolio and all that. So this is the type, for example. Or if you are a day trader, you want to see what happens every maybe 15 minutes, every 1 hour. How good is your how good is your opportunity? Is there any opportunity? The current position you are holding, is it good for you to stay in it, or you should get out? Stuff like that. So this happens like every 15 minutes. We keep checking and we get out of the trade, or we take the trade, or we make the trade and what have you. So we will set a scheduler. Now about building framework, this was what we've discussed previously. We start by discussing the strategy with the chatbot. Then we will get the code. Once we get the code, we will test it. After we test it and we are happy with the result, we will deploy it in the market. We connect to the market and then we deploy it and start to execute trades once the opportunities present themselves. Okay, so questions and answers. If there are some questions, this is the right time to ask. Okay. No question. All right. Okay. Okay. So now moving on. So what's next? Because for those who might want to leave, before you leave, I would like to say that we have had a workshop. So if this is the first time you are joining this workshop, know that we have had a workshop previously. Last week, 4 days of the week, Monday to Thursday, we did workshops on how to build a trading bot without writing code. Okay, we build 4 trading bots of different complexities. Every day we add more complexity to the bot and explain everything. So for those who are interested, we have our videos on our YouTube channel. Search for Asat Academy on YouTube. You will see the videos of last week. They have been uploaded, all of the 4 videos for the 4 days. Alright, so what we intend to do this week, we're going to talk about machine learning and how it is used to enhance trading and investing. Okay, so this is about machine learning. Then the week after, I'm going to look at reinforcement learning. Okay, yeah, there is a lot of information. I know. That's why I'm trying to see if I can minimize the content for today, and maybe tomorrow we will go into more technical aspects of the workshops, especially in terms of implementing the chatbot. Okay, so that could be done tomorrow because I'm almost out of time. I think I have taken much time discussing those things, but I believe they are important for me to talk about in a detail so that people will be able to follow. Okay, so as I said, next week we're going to discuss reinforcement learning. Okay, this is my best machine learning tool that I've used, during my PhD. The last week of January, what we intend to do is to process, news. How are we gonna have an AI that can read the news for us, and then try to gauge the sentiment of people about an asset. Okay, so if you read the news, try to see, are people happy about Tesla or not? Then that will also further enhance our trading. Okay, so this is what we will do. As I said, if you want to get the resources for the workshop, our YouTube channel is your first go-to if you want, and our app is also there. You can reach our app at asatacademy.com.ai. asatacademy.ai. Okay, let me send it in the chat. So you can just visit it, asatacademy.ai. You can be able to watch all the videos for free. Not only that, you can also be able to download the resources. We keep improving the app to further enhance and streamline the students' understanding of the concepts we are going to teach them. Okay, so we have, for example, premium features such as the teaching assistant that will be able to help students brainstorm as well as guide them and tutor them on things that they find difficulty in. We have like a module, an AI module that provides real-time feedback on assignments. You don't have to wait for the teacher, okay, to come and grade your assignment. You get your feedback. You can use that feedback to improve. You have quizzes and what have you. These are the premium features. Currently, we are still testing them, so they are also free. You can just use them as you like for now. not charging for anything. So you can just go to the app, you can get it, and you can use it. Okay, so after that, again, once more, if all this is still not enough and you still need more assistance, okay, you can still talk to me. We can have a free 30 minutes call, one-on-one. Okay, we can have this one-on-one call, and I will be able to help address this. So this is the code, this is the link. You can just go there and book a one-on-one. For example, if it is implementation you want, let's say you have a very nice strategy, investment strategy, which you want to be implemented for you, and reach out to me. Or you are trying to learn how to do the implementation, you can also reach out to me. Or you have some different application which you want to get implemented or something like that, or you just want to understand how you can use AI in your own workflow, to improve your efficiency, to improve your productivity, and so on. All right, so we have come to the end of this. The link for the meeting is in the chat. You can use it to just book your 30 minutes call, and we can have a discussion. So the bot building, we have 8 minutes. Maybe we can do it tomorrow, then I will not discuss most of these things. This video is going to be made available within 24 hours. So before our next workshop, so tomorrow the workshop is going to be at 4:15 my time, so GMT plus 4 here. So that is around 7 a.m. right, in the US Eastern time. Okay, so GMT plus 4, the next workshop tomorrow is going to be 4:15. So I think we can leave that for tomorrow. I will of course go over some of the background to further maybe explain things in a different perspective for those who join, tomorrow, and for those who attend today. Maybe if you attend tomorrow, you will also hear a different perspective, maybe hear different examples, so that it will help you build a good model in your brain about how to use AI to build a trading bot and use AI in general in the financial sector. Okay, so I think I am out of time, and the remaining time might not be enough. So this is the part I say thank you for attending. I know it's quite a lot. Yeah, we spent almost 1.5 hours going over so many things. So I know it's a lot. It's not easy. I appreciate that you guys showed up. Thank you very much. And yeah, if you have any feedback, please, you can just reply to the email, the invitation email that you received from Eventbrite, and I will be very happy to receive your feedbacks on how to improve the workshops. And if you have some ideas of what to do and suggestions, I'm very open to those as well. Okay, so thank you guys. If you have no question, then I will say have a good day. Bye.